Hello everyone, welcome back to our channel. Let me give you a quick recap about what we learned in our previous session. In our previous session, we learnt about detailing of structures which will be executed, soil and graphical detailing of R, preliminary sizing of structural elements, load calculation and its details.
So if you enjoyed this video, then please like and subscribe to Protrainy and also press the bell icon for more informative contents. Thank you.
So, with this, let's begin with our guidance session.
Provider. What is the difference between access provider and access not provider? If there is an access provided for this area, if we are occupancy, occupant means we will go to the terrace and we will have some work in terrace. We will site for siting purpose and all. We will go and there is an occupant right here. So the access is provided in this terrace area. And for headroom means no one will go every day go to the headroom and spending the times. So the access is not provided to the headroom, but only for the maintenance purpose only we will use the headroom slab. So right here in our condition, I'm going to assign the live load for terrace is 1.5 and also I'm going to assign the headroom slab as live load as 0.75 because the access not provided here except for maintenance. So next one we are calculating here is the wind load. Okay, so wind load we are going to supposed to calculate as per the IS codal provision IS 875 part 3. Okay, IS 875 part 3. So once you open the lateral load in ETABS mean the software, the dialog box will be like this. We don't want to calculate it manually. The ETABS we will ask some values, some data. We want to give the input correctly means the ETABS will calculate the value automatically. What are the value the ETAB will ask means the first one is wind speed and second one terrain category. The third one importance factor and the fourth one is risk coefficient K1 and fourth one is topography factor that is K3. So we want to give this value. So as per IS codal provision IS 875 part 3 2015, this is the updated version. Note this, we are not using the code book 1987. Okay, we are using the updated version 2015 for calculating the wind load. Okay, so this is the updated version. First one, the system asked for basic wind speed, that is wind speed VB. Okay, so we want to find the value of what is the basic wind speed. I already said that our building is located in Tamil Nadu, Chennai. Okay, for Tamil Nadu, Chennai, we want to go with the code book IS 875 part 3 2015, the annexure A. The annexure A, there is a list of cities. They already calculated the basic wind speed. So here our city is here, our Chennai, we are using 50 meter per second. If you are located in Lucknow means we use it 47 meter per second. Okay, so as per the international airports, they just mentioned the basic wind speed right here. So here I'm just taking the value 50 meter per second. So our basic wind speed is 50 and the second one is one. One in table number 1 in IS 875 part 3. So here the table number 1 right here. Yes, in page number 7. In page number 1 there is a table called risk coefficient. For the categories, the 4 type of building, the important buildings, hospitals, such buildings, and the buildings are structures presenting low degree of hazards life and the building the temporary shade. So there is not a residential building right here. If it is there is no residential building means we simply go with all general buildings and structures. Okay, so for all general building and structures based upon the wind speed is 50 meter per second. Our value is 1.0. So I just take it as the value as 1.0. And the topography factor, if the ground is straight, as per the class 6.3.3, we just use the value as 1. And also for the as per the codal, you just check by using this class 6.3.3. And also the importance factor the class 3 is 6.3.4. For all other building, the value is 1. And for terrain category, as per the class 6.3.4, our building is a complex area, so that we are using the value is 3 as per 6.3.4. Okay, we don't want to more time in this calculation. We want to switching into the software. Okay, so that next one we are going to calculate the seismic load. As per the as like the wind load, we don't want to calculate the don't want to calculate manually the wind load, I mean the seismic load. We just want to give the data what are the ETABS is asking. So what are the data means, one is response reduction factor, and another one is seismic zone factor, and third one site type and importance factor. These are the values we want to give as an input. So first one, the seismic zone. Seismic zone is listed in IS 1893 2016 here. I'm using IS 1893 part 1 2016. This is the code book will be used for earthquake resistant building. So in annexion E, there is a list of cities. So my city is Chennai here. The zone is 3 and the zone factor is 0.16. So the zone is 3 and zone factor is 0.16, and the site type I'm using the site type is 2. What is the site type? Site type is nothing but the soil type. Okay, based upon the soil, if it is a hard soil, the type is 1, or otherwise the medium soil, the type is 2, or otherwise it is a soft soil. Based upon the soil test report, I'm just using our soil is a medium soil, so I'm using type as 2. It is in page number 13. And also the importance factor, it is all other building, because the residential building was not over there. In you just go and check in table number 8 in page number 19. So I'm just taking the value as 1. And the system, our system is the SMRF. SMRF is nothing but special moment resisting frame. There are two kind of frames right there. One is OMRF. OMRF is ordinary moment resisting frame, and SMRF is special moment resisting frame. If you are detailing our structure as per the ductile detailing, as per the codal provision IS 13920 means our structure is nothing but a special moment resisting frame. If you are not considering the earthquake detailing, I'm only focusing upon dead load and live load, means our structure is OMRF. Okay, so here we are considering the seismic load, so our structure is SMRF. Once the structure is SMRF system, the response reduction value is 5. Okay, and also we want to take some percentage of imposed load, that is live load, for calculating the seismic weight. That is noted in table number 10. We will discuss this in the software area. And also I just listed some values right here, and this will be very useful for you for designing the column beam manually. And just noted some values where the check for reflection is located in IS 456. You can check by using class 23.2.1. So here all about the preliminary data. We just collected each and every preliminary data before entering into the software. Okay, so right now we are going to open the software called ETABS. So this is, we are in our session we are using the software ETABS 17 version. Okay, so ETABS 17. So once you open the software is like this only. Okay, so each and every value is hidden right here, because we want to open a file, or otherwise we want to open a new model. So right here I'm just opening a new model by using this icon. Or otherwise if you go to the file, then it will show the new model. Okay, so if you are a beginner, I'm just having the ETABS checklist. By following this if you follow this step, means it will be very useful for you as a beginner. Okay, if you're not able to leave some data, I'm just leaving that one, this one, so we don't want to having some problem. So we just simply following the steps. Totally there is a 16 steps. Okay, I'm just noted this 16 step-by-step procedure. So by using this procedure we are going to model our structure in ETABS. This is the here. So first one, as per here, is set design codes. Okay, so I'm just opening a new model by clicking this icon. Yes. Yeah. By clicking icon, there is a dialog box called model initialization. So in this here, you just click the use built-in settings with. Okay. Here, if you open the ETABS software very first time, means the display, it is American based software. So the values always in the American units and American codebook they follow. So you want to change the values as per this first one, the display units. You just just set as metric SI, and the second one is steel section database. We are in India. We are using the Indian codal provision, so we are selecting the value. I mean selecting as Indian. And the third one is steel design code. So I'm just choosing the IS 800 2007, and the concrete design code is IS 456 2000. Okay, I'm just clicking here IS 456 2000 and next OK. So as per this, second one is define grid data. Okay, define grid data. So here new model quick template, the grid data, I mean here the open, the first one here, the grid dimension. There is two grid available here. One is uniform grid spacing and another one is custom grid spacing. Okay, here we have some interaction session, I mean question answer session. The time is right here. Soundarya?
Yes, sir. Doubts I will be shared.
Yeah, down. Wait. Yeah, wait. So this is a session for the doubt. Someone asked, what is the difference of placing the landing beam and the end beam at the joint of flight and the landing? There's someone asking what is the difference between the landing beam and the end beam? So both are the same thing, because here I just show right here in the drawing. This is the landing beam. Okay, here it is maybe a primary beam or secondary beam. So this beam will be constructed right here for the support of this slab, because in this beam we just having the connectivity of the slab and also the connectivity of the staircase waste slab. So we want to compulsorily give a landing beam right here. So it is preferable. Okay. And someone is asking the question called how to calculate the loads. Yeah, this last half an hour, we just using this how to calculate the loads. We just calculated the beam load, and also we just calculating the slab dead load as per codal provision. Okay. So this session, before half an hour, we just calculating the loads only. So this may be helpful for you, and I will share this PPT to you people. You can able to use this material and calculate the loads. Okay. And third question is, what is mean by response reduction factor? The response reduction factor, someone is asking the response reduction factor. See, in IS 1893 part 1, they mentioned that the response reduction factor, there is a values, the coefficient values right here for response reduction factor. Okay. So I said that for our condition, that is if it is a OMRF and another one is SMRF building. Okay. OMRF is ordinary moment resisting frame, SMRF is special moment resisting frame. This is a coefficient value, response reduction factor. This is a factor value. It is one of the coefficient value. It is based upon the condition. With our structure, it is a moment frame system. Okay, it is not a braced frame system. Braced frame system is come with the steel structures. Our system is the moment frame system. Under a moment frame system, our system is a OMRF. I mean SMRF. We are not using the OMRF. The OMRF is ordinary moment resisting frame. SMRF is RC building with special moment resisting frame. For special moment resisting frame, the value is 5. So only I just calculated the value right here. See, I just taken value for response reduction factor. The value is 5 because the code book is also saying the same value, and also in the code book they are saying what is meant by OMRF and SMRF right here. Wait, I will show you in code book. Yeah, see right here you can able to see ordinary moment resisting frame, it is the moment resisting frame designed and detailed as per IS 456 or IS 800. Okay, but not meeting the special ductile requirement for ductile behavior as per IS 13920. It is not meeting the ductile requirement, but the special moment resisting frame is the moment resisting frame designed and detailed as per IS 456 and IS 800 and meet the special detailed requirement for ductile behavior as per IS 13920. So this is the major difference between SMRF and OMRF, so that we have the value of response reduction factor.